All right. Chapter 3, Microeconomics. Mix. This should be now lecture 6, chapter 3, and chapter 3 is, well, calculation optimization. We will not do any math over here. You don't need to do math. Math is usually killing people, okay? We don't want to do that, but you need to understand the basics. Page 69. Next. First of all, we begin with what is optimization. Let's move this a little bit here like this. Optimization. Optimization is the process of finding the best solution. The best usually means one of two things. The best will either mean maximum. Maximum means the highest possible. So it will mean maximum revenue or maximum profit. And the other meaning will be of minimum. Minimum means the lowest possible amount. Example will be minimum cost. When you run a business, you want to get the maximum revenue and the minimum cost. And hopefully, 20 minutes ago or half an hour ago, you already studied revenue and cost, did you?
Yes.
In accounting?
Yeah.
Oh, thanks God. So, you want to maximize revenue if you're a business. You want to minimize the cost. And as a business, the objective is to maximize profits. Okay, that's the purpose. So, from optimization, you get optimization techniques. And these are simply techniques or methods for finding an optimum. Optimum means the best possible value, the best possible solution. So, optimum is the best value. Optimization is the process of finding that optimum value. And optimization techniques are methods for doing it. Okay. And first of all, we now begin. This was the introduction. We get only now section 1. 3. 1. And 3.1 is expressing economic relationships. Yeah, by the way, there are something like study guide or whatever material, maybe a little bit of PowerPoint, which I uploaded in the smart learning system that you could possibly download, or you can possibly load on your phone and probably flip, but I'm just following the textbook. Economic relationships. Okay? And economic relationships could be done in 3 different ways. First one is an equation. And an equation just uses some sort of a math. Okay? It could be y equal to 3 x plus 7. I'm just making up something, okay? You've studied equation. Next one will be tables. Now, for those that were here last time, how we call these things about demand and supply before it was a curve, but it also showed up as a table. Schedule. Okay, thank you. Excellent. Demand. I'm just writing it out. That's chapter 2. Demand. Schedule is a simple table showing you for each price the quantity demanded. Okay? So at price 3, for example, coffee worth 3, you're going to be drinking 40 a month. At price 4, you're going to be drinking 35 a month. At price 5, you're going to be drinking 30. At price 10, you'll be drinking maybe 10. And at price 20, you might be drinking 1 or 2, right? This is a simple demand schedule. It's a simple table, which here says price, here says quantity, and for price of, let's say, 2, you buy 45, for price of 3, you buy 40, for price of 4, you buy 35, price 5, you buy 30, and whatever your demand is for that particular.
So when the price increases, the quantity decreases.
When the price increases, the quantity
Decreases.
No, you have to say quantity demanded. The quantity demanded decreases. How did we call this relationship, which says that when the price increases, the quantity demanded decreases? How did we call it? Law of demand. The law of demand, which you should have seen on video 4 or video 5. And which you should know because you're likely to get it on quiz number 2, because this is material from chapter 2. So you should expect to know law of demand. Now, why we say if the price increases, quantity goes down is not correct, because here's the next part. Here's the price increases, price, quantity, and price 2, maybe 2. Price 3 becomes 5. Price 4 becomes 8. But price 5 becomes 15. But price 10 becomes 100. And this is supply. Okay? And this becomes a supply schedule. So you have a demand schedule, this one, and have a supply schedule. Supply schedule. Well, here the quantity increases. That's why you cannot simply say, oh, the quantity decreases, the quantity increases. The correct way to say and to think is the quantity demanded decreases, and the quantity supplied. So you have quantity demanded, quantity supplied. Okay? So you have demand and supply. Then you have demand schedule, supply schedule. Then you have quantity demanded, quantity supply. Okay? Then you have a next demand curve. And the other one is supply curve. So, going back to what I was teaching here, there are three ways to show relationship. One is with an equation, another one is with a table like this, and third one is with a graph. And graph is actually easy to see. I did it already last time. You have some prices. Usually it's a nice, beautiful falling curve like this. And sometimes you can just hit here or hit over there. But that's what it is. The idea of falling down, we call it negative slope, is the idea of the law of demand. And let me write to make sure everybody got it, because you will likely get the question of law of supply. This is all chapter 2. Okay? And you make a graph. Let's see what else they have here. Oh, okay. You may have demand, you may have supply. Now, you may have what's called a revenue. Let me see where I'm going to write. Okay, I'll continue writing here. Revenue curve. You may have a revenue curve which shows revenues for different quantities. I'll show in a couple of minutes or in a minute. And then have a cost curve. Well, let me try and see if I can make a picture of a revenue curve. All right, revenue curve will be, let's do this thing. All right. So, revenue curve. First, what do we have? Here you have some sort of a quantity. You sell, let's say, 10 units, 20 units, 30 units, 40 units, 50 units, 60 units, and so on. You're selling a number of units, okay? And here, the one revenue would begin now is called, I'll write it in red, TR, total revenue. Total revenue. Let's write it out here. This is the amount of money that you get for selling so many products. Well, at first, you can sell the first 10 for a very high price, okay? You gotta sell 20. The price is higher, but not as high. Then you sell, but you cannot sell for as high price. In other words, the new products will sell initially, let's say, for a price of 10. Then, over time, you gotta lower the price. You wanna sell more, you gotta lower the price to 9. You wanna sell more, you gotta lower the price to 8. You wanna sell more, you gotta lower the price. So, the total revenue curve will essentially keep going like this. And at one point, even though you wanna sell more product, the price goes down sufficiently so your revenue simply doesn't go up, but actually can fall. No, it's not getting flat, it can actually fall. Because the price, now let's try what is TR. Let's try. TR is simply the price multiplied by quantity, okay? And if quantity increases, price decreases. So, if quantity goes up, it must be that the price goes down. Well, at one point, to increase quantity a little bit, the price falls down a lot. Okay? So early on, you can increase the quantity and the price falls little. But then, as you try to increase 10 more units, the price falls more. And 10 more units falls more. And 10 more units, the price falls more so that you suffer total losses. And probably I'll have an example of this soon, so you can actually see the numbers, how you start multiplying, and actually the revenue goes down. But for the moment, the idea is that this is a graph, and this is a graph of a total revenue. Well, now coming back to where I started class this evening was optimum. Well, what is the optimum revenue? If you try to think optimum could mean maximum or minimum. In this case, it means maximum. So the optimum revenue is here. Now, this optimum revenue, I gotta repeat a couple of times to make sure that students never get confused, only maximizes revenue. It does not mean that it is best for your business. What is best for your business is maximum profits. Maximum profits. The purpose of businesses, business goal, and business objective. Maybe I should write it. Business, that's coming in the next chapter. Business goal, business objective is to maximize profits. Okay. But here, it's a simple picture of what a maximum revenue is. Okay? Revenue. Maximum meaning total revenue, because there are different types of revenues. Now, this for a table is page 70. Okay, page 71 for equation. Page 71, equation 3(1). That's on page 71. If you have a textbook, you can actually open it and see it. Next one will be the table, and it's table 3(1). Again, this is the equation here. Total revenue is 100Q minus 10 times Q squared. This is the table, okay? You're gonna take a look at it, and this is a graph, okay? And that's figure 3(1). Let's see what else I have here in this particular section 3(1). Oh, section finished. Okay, so that's section 3(1). How relationships are expressed. Now, the next gets more complex. So 3(2). I can continue here. 3(2). Total, average, and marginal. Marginal relationships. Okay, let's see how we have it. All right, well, let's make a small, simple table with revenues. I'm deleting this part over here. And let's see what happens. For revenue, you got quantity. Quantity. 0, 1, 2, 3, 4, 5, I don't know, maybe 6. Now, total cost. 20, okay, total cost. This is the cost to produce, to manufacture. Well, even if you're producing 0, you still have a cost of 20. How is this possible? You produce nothing but have a cost. How could that be? Answer, English, fixed costs. Fixed cost is a cost which does not change with the quantity of output. For example, you got a small little business like ladies, hair salon, okay, or nail salon, or makeup beauty salon, okay, and that's your business. Now, if you have 2 customers or 20 customers or 200 customers, your costs will increase with customers, but you will have fixed cost. That will be your rent, whether you have 100 customers or 1 or 0 or 1,000, you have to pay rent. Now, if you run your business, you will probably use the air conditioning anyway, whether you have customers or don't have customers. That's a fixed cost. Now, more fixed cost, if you run your business, maybe you choose to have a monthly insurance. And the insurance will be relatively fixed. Now, if you're having like a reception and a receptionist and you have to pay a salary to the receptionist, maybe small, just 1,000, whether they're customers or no customers, they get paid. That's for you a fixed cost. So a business will have costs even though the output is 0. Okay, now think of this university. If the university runs and even there are no students, there will be security. You still have to pay the security anyway, right? Maybe there's a boss, maybe there's a receptionist, okay? So you will have certain staff, certain expenses, irrespective of the number of customers or the number of output. So what happens with total cost? Well, 140, 160, 180, 140, 160, 180. What's next? 240, 480. 240, 480. Well, I can come up with some other number over here. I don't know, 1,200. I'm just making up numbers, okay? So, this is the total cost. Now, the next question is, now you know the total cost and you know the quantity. The simple question is, what is the average cost? Average cost. Let's write it out. First, total cost is all the costs that you have. Fixed and we call this variable. Now, average cost. Yes, excellent. You take the total cost and you divide it by the number of units, meaning the quantity. So, what's the average cost? Well, here it's kind of like no real average cost. But here, the average cost is 140. So, the average cost here falls a little bit. Next, what's the average cost?
It's total quantity or
Yes, the total cost divided by the quantity.
quantity.
Yes. What's the average?
Maybe 80.
150.
80, yes. 160 divided by 2, 80. Next one is?
60 maybe.
Not maybe, for sure. 180 divided by 3 is 60. You should get your iToys, the phones, use the calculator. Next one is 60, someone keeps saying. Next one is 40, yes. And the next one is
20.
this one?
No.
No. It's got to be a high number, very high number. What's the next one? Well, when it divide, what's happening? So it's for 4 is 2,
96.
40. For 5 is, yes, 96. And here is, that's like 200. Like 200. So, the second concept is that of an average cost. If you're running a business, whether you're selling or manufacturing, whatever your cost, you want to know what is your average per unit. And now comes the next one, which is marginal cost. Now, we started chapter 1, the first chapter, with the so-called marginal analysis. And marginal analysis, we said, was the most fundamental economic analysis. Let's write it out here. Marginal analysis. Okay. Now, what did marginal analysis include? Question for those who scored excellent on quiz 1. What was marginal analysis? Marginal analysis, again? No, that was the equilibrium. That was called market analysis. So, marginal analysis includes number 1, marginal benefit. Includes marginal benefit and includes number 2, marginal cost. Next, the word marginal. Marginal means one more unit. Marginal means literally next. So, here, coming back, the marginal cost of 0 is 0. There's nothing, okay? Now, producing 1, the marginal cost is the difference between this and this. The difference between this and this. So, if it costs 0 to produce 20 and costs 140 to produce 1, to produce 1 more unit costs 120. Marginal cost is 120. Now, if you're producing 1 unit and you want to produce 2, you need only 20 more, the extra cost. So, marginal means next, it also means extra. Means additional.
Different.
Yes. As in difference, additional, extra. So here the marginal cost, meaning the extra cost, the additional cost is 20. So marginal cost is 20. Here the marginal cost is how much? 20 again. Yes. From 160 to 180, the marginal cost is 20. Now, from 180 to 240, what's the marginal cost? 60. Here, 240. 240. It's 480 minus 240 is 240. Okay? And then the marginal cost here is like, I don't know, 720. Alright, so what do we see here? Marginal cost at first falls and then begins to, sorry, this is average cost, falls and then rises. Marginal cost here falls and then increases. Okay, so I can draw a little bit or a big picture for you to take a look and see. So let's see, average cost is like 140. Average cost quickly falls down. The minimum is at 4 units. 1, 2, 3, 4. So average cost falls down to 4 and then rises. That's the average cost. Okay. Marginal cost starts higher, drops very quickly. So marginal cost starts a lot high and drops quickly. And then at fall, it rises very quickly. Okay. And you actually have pretty much the same picture right over here. At first, the one cost goes down, and then a little bit, and then rapidly up. Okay. That's the same as the red one. And the blue one is here, the average cost. It's pretty much the same idea. So, you have marginal cost falling and then going up, and then average cost falling and then going up. Okay, so for average cost, this is the optimum. This is the minimum average cost. So the minimum average cost is 40. The minimum marginal cost is 20. Okay? So, this is the optimum average cost, this is the optimum marginal cost. Okay? Now, we can't say what is the optimum quantity because for the optimum quantity, we need to have the maximum profit. We need revenue. Without the revenue, we cannot say which one is the best for profits. So all I'm trying to do is show you that there is a total cost, there's an average cost, and there's a marginal cost, and you need to understand these three. And then you need to understand that there is exactly the same for revenues. Let's see if they're coming. Okay, they got here some geometric stuff which I'm really not sure we should go about it, but let's try. Let's see what's the total revenue. Let's draw the total revenue. Alright, let's draw total revenue like, total cost, my mistake. Total cost. we begin here from here. It goes up. It goes like this. And then goes like this. This is the total cost. All right, let's take a look. What does it mean marginal? Okay, let's try. This here is 0 units, okay? And suppose here is 1 unit, okay? So the marginal cost will be represented by this difference here. So I'll draw it here for you to see. Okay, and now this is the marginal cost of the first unit. Okay, this is 0 units, this is 1 unit, and the difference in total cost is this red line here. Now, next is 2. Again, drop, drop, dot here. This is the marginal cost of the second unit. Next goes again the same story, but now see what happens. When the slope is steep, the marginal cost is high. Now here, it is not as steep, the marginal cost falls. Very long, shorter, even shorter. Well, guess what? It's going to get a whole lot shorter. Even shorter. Again, same thing. Even shorter. Okay. So, now notice, please pay attention here. If the slope is very steep, the marginal cost is high. As the slope goes down a little bit, the slope goes down. As the slope gets more and more horizontal, for example, here, the marginal cost is just little, okay? Now, here, the marginal cost is like big. So, high slope, high marginal cost. Falling slope, falling marginal cost. This is the lowest slope here, minimum marginal cost. Then, slope rises again, marginal cost rises too. Okay? So, rising slope, rising marginal cost, falling slope, falling marginal cost. Okay, it's actually, you can see. So, marginal cost is determined by the slope of the curve. So, high slope, high marginal, very low. This is almost flat. This is high, very high marginal cost. Okay, is that fair and clear? All right. And now let me see if I can actually show on a picture the average cost. Somehow there has to be a division. I don't know if we can, if I want to go to do that. But here you see the following: as marginal cost is falling, the average cost will be also falling too. So if I gotta draw the average cost will be falling here, and then the average cost will start rising. Okay. So here the business becomes more and more efficient, meaning the average and the marginal costs fall. And here the business we say is inefficient. So let me write it up. Efficient. Here is optimum efficiency, and here becomes inefficient. And I'll be explaining a lot more in later weeks. Yes, question?
Yes. It's stimulating, but why it's inefficient?
Inefficient is because you want to produce one more unit is extremely inexpensive. If something becomes more expensive, it means it's inefficient. If it's efficient if the cost is low, it's inefficient if the cost is high. So efficiency is associated with the cost. And 40 minutes, perfect time to take